Hey there, Prof. Aram here, and in this video we are going to go over the concept of net present value, which is one of the most common and theoretically sound decision criteria when it comes to capital budgeting. So let's get to it. Net present value, or as we usually refer to it, NPV technique, is simply the difference between the market value of a project and its cost. Remember, in the discounted cash flow model, all we're doing when we want to value an asset, we are trying to find the present value of the future cash flows and then subtract the cost or compare it to the cost of the asset. So NPV is simply finding the present value of future cash flows and then subtract the cost. That's why we call it net present value. And this is just your present value, and then since you subtract the cost, this is your present value net of the cost of the project. That's why we call it net present value. How do we do this? The first step is to estimate the future cash flows of the project. And then the second step is to estimate the required return for the project, the return that we use for discounting the future cash flows. And in the third step, we find the present value of the future cash flows and then subtract the cost. Just so you know, in this video, we're going to have these two as given. We're not going to estimate the cash flows or estimate the required rate of return. We're going to do that in later videos. But here, I'm just going to give you the cash flows and the rate of return, and we're going to use those two inputs to find the NPV of the project. So let's look at the formula for the NPV. So all we're doing for the NPV is to discount the estimated future cash flows of the project, cash flow 1 through cash flow n, using the discount rate of the firm, and then subtract the cost for the project. The decision rule here is that if the NPV that you're finding is positive, then we're going to accept the project. That means if the NPV is positive, the project is expected to add value to the firm. Let's say if the NPV is positive $5,000, it means that if you accept this project, you're going to add $5,000 to the value of the firm, right? So you're creating value for the shareholders of the firm, right? So that's why it says here, it will increase the wealth of the shareholders. And again, since our goal is to increase the owner's wealth, NPV is a direct measure of how well this project will meet our goal. In other words, it gives you a dollar amount of how much exactly you're adding to the value of the firm. So it's a direct measure of wealth creation for the shareholders. And just so you know, what happens if you invest, for example, in a project with an NPV of negative $1,000? So with the NPV rule, we have to reject this. But if you invest in this project, that means that you're going to invest $1,000 today and receive nothing in the future. In other words, if you invest in this project today, you're going to decrease the value of the firm by $1,000 immediately. You're going to destroy value for the shareholders. So that's why the decision criteria for NPV is you accept if NPV is greater than 0 or positive. Now, let's answer the questions that we had before. Does NPV consider all the cash flows of the project? The answer is yes, because you have cash flow 1 to cash flow n. So you have all the cash flows here. So the answer to first one is yes. Does it adjust for time value of money? Again, the answer is yes, because you are not using the nominal cash flows. You're finding their discounted values or present values. So the answer is yes and yes. Does it adjust for risk? The answer is again yes, because you're using the firm's discount rate here, and you're finding their present values. And finally, does the decision rule provide information on whether we are creating value for the firm? And the answer again is yes, because it gives you a direct measure or a dollar amount of how much value you're adding. So the answer to all of these questions should be yes for NPV. And that's why NPV is the most theoretically sound and the most rigorous measure or technique to evaluate long-term projects, capital budgeting projects. Let's look at an example. Say we have a project that will cost $165,000 today. So today's cash flow is $165,000. We call this the cost of the project or the outflow of the project today. And then your forecast or your estimates show the cash flows for years 1. These are your future cash flows that you need to find their present value. Cash flow in year 1 is $63,120, $70,800, and $91,080. Right? And your required rate of return or your discount rate is 12%. How do you find the NPV of this project? If you use the formula, NPV would be the present value of the first cash flow, 63,120 over 1 plus the rate. Second cash flow is 70,800 over 1 plus the rate squared. And then we have the final cash flow, 91,080 over raised to the power of 3. And then you're going to subtract the cost of the project, which is $165,000. So the answer for this should be $12,627.41. Now let's try the financial calculator and see how can we calculate the NPV using the financial calculator. In fact, we've already tried it before, but without entering the cash flow 0. So to do this, we are going to use the cash flow function. So cash flow function, you just push the cash flow button here and then clear it second C, so there's no number here from the previous problems that you've done. Now, it's asking for cash flow 0. Cash flow 0 is 165,000. And because of the sign convention, we have to enter it at a negative number because this is the outflow today. So if we push enter, and then we go down arrow, cash flow 1 is 63,120. Cash flow 2 is 70,800. And finally, cash flow 3 with 91,080. After you're done entering the cash flows, you just push the NPV button here and then enter the rate of 12% and go down and compute NPV. You should be getting exactly the same number as we had before, 12,627. Now let's look at the Excel spreadsheet. So for Excel, it's a little bit different. For Excel, when we use the NPV function, it's asking for the rate, which is 12%, and then the values or the cash flows of the project. So we're going to use only the future cash flows of the project and close the parentheses. The reason that we don't enter the cash flow 0 is that the Excel assumes that these cash flows happen at the end of each period, but 165,000 is today, it's the beginning of the period. So because of that, we can't really include the cash flow at time 0 in the formula. So what we're doing here is that we are going to find the present value of the future cash flows and then subtract the cost of the project. So it's a little bit different in Excel than it is in the financial calculator. So make sure you find the present value of the future cash flows first. So in the NPV function here, just include the future cash flows and then add the cost of the project. Okay, let's do another one here. We have another project with a discount rate of 9%, and it will cost $55,000 today and provides no cash flows in the first 2 years, and then these 3 cash flows after that. So all we're doing here, again, we do NPV. The rate is 9%, and then the cash flows, you start with cash flow 1, and then add the cost to the project. So in this one, the present value of the project is, the NPV of the project is negative 7,947. So we will accept this project because the NPV is positive, but reject this one because it gives you a negative NPV. Okay, I hope you find this video useful, and thank you for watching.